Stars coming back to life after exploding is not a usual situation. However, there are some stars that manage to survive a supernova explosion. These kind of zombie stars are very rare. Scientists discovered a rather large star named LB 4365. It's thought to be a somewhat flawed white dwarf, which are stars that have burnt all the hydrogen they once used as nuclear fuel. In this case, it's thought that the final explosion wasn't strong enough to completely destroy the star, as if the star had a failed explosion attempt but still partially survived. This remnant of a star could be a white dwarf, or it could be remnants left from its explosion, continuing to feed from nearby stars and manage to be noticed. If one day you go to the moon and see footprints there, it doesn't mean you're not alone. Since the moon doesn't have an atmosphere, those footprints or similar markings can last for millions of years. There are no strong winds or tiny interruptions to cover these footprints. In the vacuum of space, you can weld two metal pieces together just using your hands. Actually, this situation is not related to physics. The only thing you need to do is touch the two metals together. In our atmosphere, oxygen forms a thin layer on the surface of metal. This oxygen acts as a barrier. But in space, since there's no oxygen, that barrier is lifted. If you go into space, never take off your spacesuit anywhere except inside a spaceship. Otherwise, the oxygen in your lungs and the rest of your body will expand like a balloon, swelling up to twice its normal size. The good news is that your skin is elastic enough to hold you together, so you won't burst. If, for instance, you were to cry from watching a touching movie, the saline will gather around your eyes, causing a burning sensation because your eyes will be dry. All the fluids exposed on the surface of your body, including the surface of your tongue, will evaporate. While we're on the topic of burning, it's worth noting that fire can't spread in space. Fire can only spread where there's oxygen, and there's no oxygen in space. If a fire breaks out inside a spaceship, simply shutting down the ventilation system would solve the problem. However, in an area where there's a lot of smoke and melting objects, the situation can get a bit complicated. Conventional foam fire extinguishers that we use on Earth won't work as they disperse randomly in space. Researchers today are working on a system to extinguish fires using sound waves. The intensity of the sound determines the size of the fire it can extinguish. But this sound can be at such a high frequency that it might deafen the astronauts. Black holes are not objects in space that swallow matter due to their intense gravitational pull. When an object gets too close to a black hole, specifically when it passes what is called the event horizon, it disappears. There's no turning back. However, according to quantum physics, nothing can completely erase data. This presents us with a major paradox. Stephen Hawking introduced a theory suggesting that there might not actually be an event horizon. Perhaps there are only apparent horizons that temporarily trap matter, and the trapped energy might later escape in a different form. When an object enters a black hole, its shape changes and it stretches out like spaghetti. This is because the gravitational pull squeezes the object from one direction and pulls it from another, just like in the spaghetti paradox. By the way, the mass of a black hole as small as an atom is greater than that of a large mountain. The mass of Sagittarius A*, located in our Milky Way galaxy, is billions of times that of the Sun, but luckily, it's very far from us. There are more than 23 days worth of space debris orbiting our planet at speeds of up to 28,000 kilometers per hour. Their total number exceeds 500,000, with most of them no larger than a bicycle. These generally consist of natural meteorite fragments and artificial debris we produce on our planet. Meteorites orbit around the Sun, while most human-made remnants are in Earth's orbit. For instance, from various parts of Earth and spaceships, we have sent nearly 9,000 vehicles into space. Even very small particles can damage a spaceship at such high speeds. We can see galaxies, planets, comets, asteroids, stars, and celestial bodies in space, but these only make up about 5% of the universe. One of the biggest mysteries of the distant universe is dark matter. We use this term to describe the part of the universe we can't see. Furthermore, it is believed that dark matter constitutes 25% of the universe. The remaining 70% consists of dark energy. Although scientists still don't know much about this, they believe that the accelerating expansion of the universe is due to dark energy. On the other hand, dark matter slows down this expansion. If we could interact with dark matter in any way we're familiar with, we could locate galaxies, planets, and other bodies. Astronomers have found the largest void ever observed in space. This void spans billions of light years. Interestingly, it was discovered by accident when a researcher from a team got bored and wanted to check what was happening in the direction of the cold spot. This could be related to the CMB, or cosmic microwave background, a cold glow that fills the universe and originates from the Big Bang, which has been traveling through space for about 14 billion years. However, instead of the expected CMB, they found a region that was much colder and larger. The research team began tracking radio waves but did not find any substantial radio waves, meaning what they found is not a galaxy or a star cluster. Also, since it's very cold, it cannot be dark matter or regular matter. It's a void, and researchers think it's made up of dark energy. Light can still pass through it. Even if it's not the only void we've found in space, it's certainly one of the largest. If a star's surroundings are not too cold or too hot, and it's conducive for the existence of liquid water, it's suitable for life. Imagine if Earth was located where Pluto is. Since it's so far from the sun, our oceans and a large part of our atmosphere would freeze. On the other hand, if our Earth were located where Mercury is, it would be so close to the sun that all the water on its surface would evaporate. Areas like these are called habitable zones. Thus, we can see where planets are located and if there's a possibility of life on their surface. However, one of Jupiter's moons, Europa, breaks this rule. Although it's outside the habitable zone, it's still warm. The source of this heat isn't directly from the sun. Instead, gravitational interactions with other satellites send energy to Europa. As Europa moves in its orbit, its shape changes, much like how the gravitational forces of our moon cause tides on Earth. When a solid substance experiences this, the object is subjected to pressure. This pumps energy into the object, much like playing wall tennis. Before starting the game, if you hit the ball against the wall a few times, you can think of it this way: each time you hit, the ball changes shape. Even though the surface of Europa is frozen, there are cracks. Between these cracks, you can observe ridges in the ice. Then, ice masses move and refreeze. You can observe a similar situation when flying over the Northern Sea during the winter season. Europa doesn't freeze entirely. Scientists think that there could be liquid oceans beneath its ice-covered surface. Europa is not the only moon experiencing this. One of Jupiter's other moons, Io, is warm due to tidal forces. Moreover, Io continuously experiences volcanic eruptions. Therefore, the only thing that warms planets and charges them with energy isn't just the sun. Many experts agree that the universe will end 3 to 22 billion years from now. The universe is continuously expanding, indicating it was once compressed. If there was a beginning, there probably will be an end. However, please note that we won't be around by then. According to a popular theory, the expansion of the universe will slow down, and eventually, gravity will cause the universe to shrink. It will become a big contraction. This will bring chaos with it. Stars and other celestial bodies will move, collide, and thus destroy each other. We can think of it as the opposite of the Big Bang. Although we've shared such a bleak outlook, continue to have a positive perspective on life. Thank you for diving deep into the mysteries of our universe with us here on Mysterious Discoveries. If you're as intrigued by these enigmas as we are, please don't forget to give us a thumbs up. And if you haven't already, hit that subscribe button so you won't miss out on our upcoming journeys to the unknown. Remember, there's always more to discover, and together, we'll continue unveiling the secrets of the cosmos. Until next time, stay curious and keep exploring.